Hi everyone and welcome back. In this video, I'm going to show you how to start our project from completely a bare hands project. So first thing to do is to add dependencies to my project. Let's navigate to my libs.version.files. The dependencies that I'm going to use is Hilt, JSON, WebRTC, lifecycle ViewModel for Compose, the Firebase libraries, Hilt navigation, KSP, and Compose, of course. So let's make sure that you add the right dependencies like this, and then we will navigate to build.gradle, the app version. Up here, we are adding these 3 lines here inside the plugins. And down here, I'm gonna add these libraries like this. Also make sure you add the plugins inside the build.gradle properties for the project version. So right here, I have my Google JSON service. It means that I have already connected it to the Firebase application. But if you don't know how to get that file, I'll simply remove it and do it with you one more time. So if you build this project right now, you should be able to see that Google Service plugin is complaining about not existing the Google Service JSON. So to do that, I'm going to go to console.firebase.google.com and create a new project. Let's name it my WebRTC project, whatever that you want. It doesn't matter. Then press continue, and simple like that. Press default account. Now wait for the project to be finished. So let's continue, move to the project. Before adding Android app, we should enable real-time database, create a database, then select a real-time database location. I'm gonna choose Europe one, and then press enable. Now let's navigate to the rules section and making these two to the true. So we have access to read and write to our database, but it's announced that your security are defined as public. So you have to read the documentation to set proper data policy for your real-time database later. But this we will leave for now. Let's go to the project overview and then add an app. We choose Android, of course. It's time to add your package name here. Let's move back to my source and copy my package name. Simple as that. Paste it here. App name, my awesome app. Let's register the app and then download the Google JSON service file. So press next. We have the dependencies. Press next, continue to console. Right now we have the Google JSON service. To use it inside the Android project, we should make sure that we are inside the project tab and simply inside the app folder, we are going to copy it and paste it inside the app folder. Let me remove this 7 number because I have already done it 7 times. Press OK. To make sure that we are connected to the storage, you should make sure that this line exists. If you download the Google JSON file without adding Firebase database to your Firebase console, you won't be able to see this storage bucket. So everything is good now. Let's rebuild the application. Okay, we are good to use the Firebase service right now. Now let me close everything else that we don't need right now. Like always, I'm going to switch back to Android preview and add the required permission to my Android manifest file. So let me copy and paste it here. Do not waste any more times. Let's create this name declaration. So we added the runtime permissions. Then inside my main screen, later I'll run the required permission dialog to grant the permissions. So the permissions that we are using are camera, of course, record audio for transferring sounds through the microphone, internet state for, set up the calls, and also the network state is the same for these three. And modify audio setting is to switch to the loudspeaker, to the main speaker. Otherwise, you should hear the voice through the top speaker of your phone that you always listen the call through that. So let's go back to the main structure of my application. Right here, let's start with adding required packages inside my UI package. So let's create a package and name it components, and another one named screens, even if I have only one screen at this project, and the last one, the ViewModel. So we can copy and paste the components to this application to save times and not writing it all over again, but I will explain it to you. Let's start with call control section. This section that you see here is actually this part of the UI and has the text field that we enter here and press the ID that we want to call, and the button that says call and does the action of doing the call. And footer section is nothing special, but this part here that you'll follow my channel, of course. And surface view render is an Android view that adds a surface view render from the WebRTC library and wraps it inside a frame layout. And whenever the surface is ready, we will notify that the surface is ready and ready to use. So it's nothing shiny, but just a simple WebRTC surface view render that we use it inside the Compose, which is this view and a small view down here to transfer the images. And of course, the top bar section, which requires the ID that I'll add it inside the application later, is this one that shows your ID. And of course, video section footage is this part that wraps two surface view render inside a box and on top of each other. One of them is our remote surface view render, which is this one that fills the max size of this component, and the next one is the local surface view render that is down here. Nothing shiny, but simple UI to set up our video call. As I mentioned before, we don't focus on setting up a good UI or a good UX for the video call, but just chain of video processing to collaborate WebRTC with AI or with ML-Kit models. Now let's go ahead and bring that main screen to my screen package. I'll just copy and paste it. I don't want to waste any time to write anything, but just want to show you how the functionality of this project is working. We might see some errors here because I haven't implemented main ViewModel here yet. So let's add it again to my project. Let's copy and paste it inside the ViewModel package. Okay, so I added ViewModel here, but there are lots of things that is missing that I have to add to the project. But since I have implemented everything from my ViewModel, that doesn't matter to me. So I'll close the ViewModel for now and I'll fix it later. So right now we are handling the UI part. And also, of course, let's add it inside to my main activity like this. And of course, before we forget, we should annotate this main activity as Android entry points. And let's create a package here and call it DI. And of course, another package named utils. I will add my application class here. So my application, the name doesn't matter. We just want to, of course, annotate it as Hilt Android app, and we are going to extend it from the application class of Android.app package. and add the name of it inside my Android manifest file from the utils package, my application. And of course, I'm going to need that UUID file here that I'm missing. Let's add it inside my application file. So it's our user ID variable. Down here, I'll create a companion object and add this user ID as a static variable. So we are creating a random 2-character string and provide it inside the entire application. And down here, I'm going to implement it like this. So back to the explanation of main screen. Let's close the extra stuff that we don't need here. Up here, we'll create our ViewModel instance, and below that, we have the call state. This state represents our application if we are inside a call or we are waiting for the target to answer and everything like that. So let's take a look at it. How does this call state look? It's a mutable stateful of Boolean that we want to set it to the true if the call's set up successfully. And this part is for permissions. We are going to request multiple permissions to grant the permissions that we need for our application to run, that we saw inside the Android manifest earlier. And using a launched effect with a key of unit that runs one time, we request for the record audio and camera permissions. And below everything, we set up a column to hold our top bar on top of everything and call control sections. And of course, a footer section for our footer inside the main UI. Nothing fancy. Everything is simple. We just have 2 surface view render to set up the call and a text field to start a call. So to set up the Firebase, I'll actually use the dependency injection to handle that one. I'm gonna copy and paste on my app module inside DI. This class represents my dependency injections, actually the unique models that I'm going to use application-wide. It's going to provide JSON objects and provide the context. And of course, Firebase database instance, and using that instance, we are going to get the database reference. So that we have set up the UI, it's time to set up the signaling client. I'm going to create a new package and name it remote. And first thing that I'm going to add to this package is Firebase field names. We have the users node, and inside that we have the data. Whenever we want to query for a user, we will first find the user ID inside the users node and then observe the data of it. Simple as that. And the next thing that I'm going to add is signal data model, of course. Let's copy it here. Let's see what we have inside our signal data model. A signal is a simple packet that we send for the target that in order to notify that we want to communicate with you. But here is my ID. Actually, this participant ID is the ID of the sender. I should have renamed it to the sender ID. So when I receive a signal data model, I know who is sending this packet for me. And the type of it is very important. Using this type, I can understand if it's an incoming call, if the call by the target is accepted, either it's offer or answer or an ICE candidate. And of course, the data is going to be a string. And we are serializing it using JSON and then deserialize it when we want to receive from the target. Simple as that. So the next thing is Firebase client. Let's add it to the project. Right here, we have our user ID imported from my application. I'm going to implement database using Hilt to my Firebase client, and of course the JSON object. You know, every call to the Firebase database requires an event listener that has 2 functions, on data change and on canceled. Because I'm not going to use uncancelled one here, I'm going to create my own value event listener and use it inside the requests. And here I'll remove one failure. I don't want to see the logs. So what we have here is each user should listen to incoming calls inside his data node. If you take a look at here, this is an reactive program that uses a callback to notify consumer that says that a new signal data model is received. So how does it work? We are setting a value event listener to the nodes of the users and the nodes of user ID, which is our own user ID, and then inside the data field. So it means that if somebody put a data in your pocket, you will notify using this onData change listener. And what we do here, of course, we transfer it back from the serialized version to the deserialized version. Simple as that. Using JSON, we achieve that. And then if the deserializing was successful, we will use the callback and emit to the consumer. Simple as that. And down here, we have two more useful functions. The first and very important function is to update participant data model. Actually, all that this one does, it's getting the target ID and data model, and we find the user inside the user's node and set the signal data model inside the data node. And using JSON to JSON, of course, we serialize it to a simple string and press wait to suspend the function to make sure that everything is done. And of course, this one is just remove our own data node. And this one, the clear object will cancel the parent coroutine to stop transaction that we don't need anymore. Right now, before we dive to our ViewModel, I'm going to add my WebRTC package and dependencies that I need to use it. I'm going actually to copy and paste it inside my utils package and name it WebRTC. So let's close everything and start with the RTCClient interface. So we have an interface or a blueprint for our WebRTC client. And using the functions down here, we are going to set up the signalings for WebRTCcall. So let's take a look inside the implementation of these files. We are going to override the PeerConnection function, the value that is derived from the constructor of this class. So also we have a transfer listener. It's a callback inside this class that will notify the consumer that there are three callbacks that you have to handle inside this class. The first one is when the ICE candidate is generated, you have to handle it. The next one is when the offer is generated, and the last one is the answer is generated, because we used to transfer these session description and ICE candidates to transfer to the other guy. So up here again, we have the offer function. All it does is using PeerConnection, we call the create offer function. And as the observer, if you check here, it's going to use a session description observer and a media constraint. The media constraint we have created up here, but session description observer is a large function that if you want to use it, you always have to implement these for override function over and over again. So all I've done is the same as the value event listener for the Firebase. We create an open class and extend from session description. So using that, we can only use the function that we want. And in case of creating offer, you will receive a session description, which is the session description of the offer. So the first thing that you have to do is to set it as a local description. And this function, of course, requires a session description object as well. So we don't care about this successfully or handling other cases. We just know that we want to set up a simple call. It's not the real video call application. When we successfully set it as the local description, we want to transfer it to other guy. So we simply use the transfer listener and call the onOffer generated callback. Same goes for answer, but with a different callback and different create answer function. And of course, we had few more functions. When a remote session receives, we want to set it to our peer connection as a remote description. Simple as that. When the ICE candidate is receiving, we will do the same and add it as the ICE candidate. And of course, if the local ICE candidate is generated, we first want to add it to our peer connection and then transfer it to the other guy. Simple as that. But right here, let's take a look at our WebRTC factory, which helps us to prepare the WebRTC factory, the requirements, and create this RTC client implementation. So as you know the basics, we want to have the EGL-based context to set up our UI renders and peer connection factory that creates the peer connection for us. Of course, we are going to need our video and audio sources. We are going to create it by using PeerConnectionFactory, create video source and create audio source. And a video capture to open your camera, and we will set up it down there. So these two audio track and video track will be responsible to write the microphone sounds and camera data to the actual connection, actual WebRTC connection. And we will set up this down here. So we of course have some ICE servers inside this file. You have to add it here. If you create your own ICE server, you will add it here. If you don't know how to create ICE servers, I'll have a video that puts top here inside this application. You can also watch the video and know how to set up your own turn server. And then you will set up PeerConnectionFactory. Before you create a PeerConnectionFactory, you have to set it up. So how does it work? Simply, we will create the options for our PeerConnectionFactory. The requirement fields will be added to the options, and then use initialize and pass the option to it. And using PeerConnectionFactory that initialize will set up the PeerConnectionFactory. And the next one is the create PeerConnectionFactory. This function will generate an instance of the PeerConnectionFactory, and using the builder pattern, we set up video decoder, video encoder, and options, and then create a PeerConnectionFactory. Simple as that. So down here, you can see we lazily create this PeerConnectionFactory and pass this function. And so the app knows how to create a PeerConnectionFactory. Now that we have our PeerConnectionFactory, we know how to create a WebRTC or an RTC client. So we will create a function named createRTCClient. And of course, we want to have an observer of the peer connection and see what's going on inside the WebRTC connection. Is the remote video added or the connection set up successfully and stuff like that. And then call back for the WebRTC to know that if any ICE candidate is generated or any session description is then generated. And so we pass everything using these function variables. And then all we do is to create a peer connection factory using create peer connection function and the peer connection factory instance. And then for the configs, we simply pass the ICE server and the observer to it. Then we will add the local video track and local audio track. Of course, we want to make sure that these are prepared before we create an RTC client. So these two variables will be instantly created when we open the application before we set up the call. You will see it in a quite few seconds down here. And then after adding these two tracks to our connection, we are ready to pop up the objects and drop this RTC client out of this function. So our RTC client is ready to use. But let's see how we can set up and prepare these two tracks. So before you use any surface view render, you have to prepare it or initialize it. So this function will be called on both remote and local surface view renders. All it does is just set the mean over to false and initialize this function using EGL based context. And we don't want to have a events render for these objects at this project. For example, to prepare the local stream, first we have to prepare our surface view render, and then we pass this surface to start local video. So let's see what's happening inside this start local video function. All we do is we prepare our surface texture helper, and using that we are going to initialize our camera and then start recording or start opening the camera and receiving the image. So let's see how this get video capture will get us the API to the camera. It simply use a camera to enumerator and then check for the available cameras and simply opens the front camera. Then you can use the switch camera function to switch to the other cameras. If there are second or third camera or back camera, you can use this function to switch between cameras. Up here, we got our camera to enumerator object using and save it inside this video capture instance. Now we should call the initialize function and pass the textual helper and the context and of course the capture observer. Then we start to capture with width and height and of course the frame per second here. Now using this video capture, we started to capture, so our sources now are available to have image inside them. And using those sources, we are going to create our video track and audio track. Simple as that. You can see when we start our local stream, both of our video and audio track are prepared and ready to use. So no worries about being null inside the PeerConnectionFactory if you want to, set up a call. So everything is prepared. But before this video gets any more boring, let's go back to our ViewModel and check if we missed something here and take a look at how the functionality of this ViewModel or the application works and how does the flow of the application work. Let's take a look what we have inside main ViewModel. We are injecting Firebase client, application RTCClient and JSON objects inside this ViewModel. We set up RTC audio manager class. This class is written to be used to switch between audio sources or speaker sources. Initially, I want to set up the audio source or speaker source to the speaker phone. So you want to hear the audio loudly when you set up the call. Now it's time for the main magic, which is this permission granted function that is going to be used inside my main screen. This main screen was in charge to grant the permission from the user. So if the permission was granted, it means that we have access to open camera and microphone. So right here is time to set up the signaling part, which is using Firebase client. If you remember, we had an observe incoming signals. We are going to listen for the incoming signals. And of course, if you remember the signal types, we had these 5 type of signals: incoming call, accept the call, offer and answer, and ICE candidates. So on each case, we want to handle what happens if an incoming signal data model comes to our data section inside the Firebase Realtime Database. If an incoming calls received to our data section, we simply want to store the participant ID inside our ViewModel and then using the data model participant ID. As I told you before, this ID is for the sender. So this user knows who is interacting with. And then we update the call state to the true. That means that we are inside a video call. Initially, we want to accept the call. So we don't want to show any yes or no for incoming calls because this is a test implementation. But if you want to add a yes or no call, this is the place that you want to update your state that there's a incoming call. If you want to answer, if a yes, then you want to launch this, block and update the participant data section to that, hey, we accepted the call. So imagine that we send a notification, this guy accepted, and we received back that the call is accepted. So what we do is we set up an RTC connection. If you remember, this function is responsible to recreate or create our WebRTC clients. So using WebRTC clients, we will create an RTC client. As the observer, if you remember, we want to add my own peer connection observer. So if you're wondering what's inside it, it's a simple implementation, an open class to, get rid of all of these implementation inside your ViewModel and get your code dirty. So most part, we simply want to use an ICE candidate and on connection change, and then on add track implementation that you see here. We have 3 callbacks implemented here before you get lost inside the next part of this object. We want to check what happens when we are observing the WebRTC state. So we simply say if any ICE candidate is generated, we want to use our RTC client on localized candidate generated. So if you remember this one, we added to our peer connection and then transferred to the other targets. We will get to the transfer target quickly. And if any stream is added, we want to sync it inside the remote surface view object that we initially save it inside our view model up here. So if you take a look at that is happening inside these 2 functions. So we have 2 functions that interacts from the main screen. If you take a look at init remote surface view, this function happens when the remote surface view gets ready and the local surface view gets ready. So these 2 functions will be called, and we save the remote surface view because we know that after setting up the connection, we want to sync the image inside this remote surface view. That's why we have an access inside this observer, which was right here on add stream. We wanna check if the remote surface view is not null. We wanna add the video track with the first index to the surface view. And of course, we wanna monitor if the peer connection state is connected. We simply want to remove the self data to avoid conflicting next calls and stuff like that. It's not the necessary part. You can remove it right now inside this application. So this is our observer for WebRTC, but for the callback, of course, if you remember, there was a transfer callback that we had to implement it, whoever uses this RTCP implementation. So what happens here if these 3 function is getting called? So the first one is when an ICE candidate is generated. Of course, we wanna wrap it inside the signaling data model. So we use the Firebase client object and update participant data model. We know who the participant is because this is derived from the setup peer connection. And then we know what the data model is because the type is ICE candidate exchange, and the data, of course, the ICE candidate serialized one, and then participant ID is our ID that we are sending to the target. And same goes for the offer and answer. We simply want to create the data model, set up the title for the offer and answer, add the descriptions to it, and then add our signature to the package model and send it to the other target. And in the end, return the RTC client. Now that we know how to create an RTC client, let's go back to our first scenario that accept a call. Okay. Now, after we accepting the call, we will going to create an offer. So the person A will send the offer to person B. So person B will receive the offer. So the function name is handle received offer. Let's go back inside the handle receive offer. As you can see, we are setting the call state to the true. It means that we are inside the call. And then we again set up the RTC connection for other user B. And after creating the peer connection, we will add the session description of it to our remote session description. Then we will create an answer. So if we press an answer, the answer will be generated, and inside the setup RTC connection, you can see that if the answer is generated, we want to transfer the generated answer to the target. So guy with the name of A will receive the answer. So what happens if we receive the answer? We simply want to add that session description as a remote session description. And meanwhile, if any sort of ICE candidate is received, we want to add it inside our peer connection. Simple as that. So that we know on each case what's going to happen, we go back to our main screen and check how our main screen is doing the work. So if you press the call button, which is called control section here. So if you press the call button and we know the participant ID that is derived from that text field, we send the start call signal. So if you take a look here, you can see the start call signal goes using this function. All it does, it's going to update the participant to incoming call. Simple as that. And the rest we have covered so far. So before this video gets any longer or any bigger, I would like to run a test and show if this system is working. Before we move to the next video, I want to make sure that I have implemented everything. If any bugs occurs, I want to fix it with you guys. So let's permit the permissions on both sides, write the targets, user ID, and press call. And we can see that the local stream is being started. I guess I forgot something at the first step. So right here, we want to set up our Firebase app when the application goes up. So we use initialize and pass this as the context. Using this, our Firebase initialized when the app goes up. Let's relaunch our application. And I'm going to run it inside my real phone and inside an emulator. You can see if I write the ID and press call, we successfully will set up the call. So that's it for this video. Let's move to the next video and start working with ML Kit libraries.